So finding volume of a solid of revolution. Make sure that's stim it out. All right. So first, we're going to sketch the area bounded by the equations y equals x squared, y equals 0, and x equals 2. So x squared we know 0, 0, 1, 1, 2, 4. Okay. Y equals 0 is just the x-axis. And x equals 2 is right here. So what we're going to do is we are going to take this area and we are going to revolve it around the x-axis. Okay? Now, what I have found was there's a nice little program I found. Let's see if I can... Where'd it go? Here it is.
Why are we going to need this?
See, we have... Oh, fun. Oh, it's not let me do... Okay, squared. Lower limit is 0, upper limit is 2. All right. So this lets me show you the graph. All right. Now, I could not tell you what C and D are, or why these little lines here. All right. So there's our graph. There's our area bounded. Okay. Now I'm going to turn this a little bit so you can see this. What we're going to do is we are going to rotate this around to create a three-dimensional solid. So again, kind of go back and forth. This is rotating around. So, right, that's what it looks like from the top view, kind of. Right. So unfortunately, like, that's all it's going to look like from the top, is that. Like, if we put it on paper, that's what we're going to see. Okay? But this is actually what it is. Okay? Is this whole volume right here. All right? So I like this thing. It's real nice to play with. All right? So again, that's a whole, but yeah. Yeah, if I want the volume of an irregular shape object and I know the function giving the bounds of the shape, then yeah.
What's that?
So
Hey man, it's right question and thoughts here. And watch it. Watch it.
Now to draw this on paper, what we're going to do is just mirror this over. Since we're going to reflect this or rotate this around the x-axis, we're going to mirror this over the x-axis. So we have our point here and here. And usually we shade it kind of just like there it's shaded. All right. So here it's shaded. And we draw kind of like some like circles, ellipse type circles to give it that false sense of a three-dimensional object on a two-dimensional plane. Okay. So, all right. Now, what would the cross section, if I took a little section of this little section right here, what would that cross section look like? A circle. Okay. And how do we find area of a circle? Pi r squared. Now, in this case, what's the radius of the circle? What's the radius of my circle in this case? The function. Okay, whatever f of x is. In this case, it's what? Radius is y, which is f of x, right? Yeah. Radius is the y value, which we find the y value in terms of x. So whatever my function is the radius. Okay? Now, generally, we're going to call this r of x for radius in terms of x. All right? Now, we use capital R, and there's going to be a reason why you're going to see later on why we use capital R. All right? Because the nice thing about this one is there is no gap inside this revolution. Okay? It's one nice whole little function. All right? So, what is the area of one cross section? For this function, specifically the area of one cross section, area is equal to pi times r of x squared. In this case, that would be pi x squared squared. Then how do I find the volume of the solid? Well, what does my function go to? What are my bounds of my function? 0 to 2 of pi x squared squared. dx, don't forget dx. So, volume is equal to pi times r of x squared dx, where r of x is the distance between the axis of revolution and the outside of the solid. So number 2, we are going to take a region bounded by y equals e to the x, y equals 0, x equals 0, and x equals 3. Okay, so graphically, e to the x is starting at 1, and then just goes up like that. So from x equals 0 to 3, and we're going to rotate this around the x-axis. Now, is it important to know what function we're going to rotate around the x-axis? Is it important to know which axis we're rotating around? Yeah, because how is that going to change our equation? Because if we're rotating around x, your function should be in terms of x. If we're rotating around y, your function needs to be in terms of y. It's kind of nice. Tells you what to put your function in terms of for this one kind of question. Tomorrow, we're going to do rotating around lines other than an axis. That's when it gets a little more interesting. So we're going to mirror this shape again, starting -1 down here, 3. So mirror the shape over, and we shade however we like. And then draw your circles here. In this case, we have that. And so, loop. All right. So, again, it's not too terribly hard to do. We're integrating from 0 to 3 for my bounds for my x. My function is just e to the x, so e to the x squared dx. All right, no calculator. Now, with pi, we can bring the pi out because it is just a constant. E to the 2x dx. How would we do the integral of this? I mean, technically, you don't have to do u substitution if you just know what you're doing. Okay? But it does make it a bit easier to see what's happening. All right? Because if we did the integral of this, we'd have to deal with the chain of the 2x, right? What's the derivative of e to the x? E to the 2x? Yeah. 2 e to the x. So how do we get rid of the 2?
1.
So 1/2. So pi, again, if you want to do u substitution, it'll bring out the 1/2. From 0 to 3 of 1/2 e to the 2x dx. Well, not dx, that is actually the integration, sorry. That is the antiderivative. So 1/2 e to the 2x from 0 to 3. So this is going to give me pi times, well, I'm going to bring out the 1/2 too. Pi over 2 times e to the 6th minus e to the 0, which is pi over 2 e to the 6th minus 1. And there you go. There's your volume. Yes, it's fine.
Where does the 1/2 come from?
If you want to use substitution, it's like 2x is equal to, or u is equal to 2x, so du is equal to 2 dx. You have to have the 1/2 to get rid of that. Just dx. So yeah. So instead of doing that, we just accounted for the 1/2 will be there. All right. Take the region bounded by y equals 4 minus 2x, y equals 0, x equals 0. Revolve around the y-axis. All right. So here we have our function. 4 minus 2x starts at 1, 2, 3, 4. And by 1 we're at 2. By 2 we're at 0. It's just nice little here. Okay, mirror. Let's mirror that over here. And we're going to rotate this around, forming a nice little cone. Which in this case, if you knew the volume of a cone, you could probably solve this pretty easily. Remember how to find volume of a cone?
No.
Yeah. 1/3 area of the base times the height. So since the area of the base is, yeah, so since the base is a circle with a radius of 2, area of that base is 4 pi. All right, height is 4, so what's 1/3 of 4 times 4 pi? 16 pi over 3. So there's your volume, because we know how to do volume of a cone. But guess what we're going to do? We're going to do the integral. Now, this needs to be in terms of y, doesn't it? So first of all, this is not in terms of y. So we are going to say subtract 4. So y minus 4 equals negative 2x. Divide by negative 2. Negative 1/2 y plus 2 is equal to x. So there's my function. Now, what are my bounds for the y? What's the lowest value for y? 0. What's the highest value for y? 4. Of just this function, so negative 1/2 of y plus 2 squared dy. Oh, I did forget pi. I'll put pi there. Good catch. Don't forget pi. All right. Now, this is the same thing as saying pi integral from 0 to 4 of this squared is 1/4 y squared minus 1 times 2 negative 2y plus 4 dy. Never forget how to quickly square a binomial. Square the first term, multiply the terms together, double it, square the last term. Yes? No? Okay, I thought you had a question. All right, so what's the integral of that? So pi. Now we got to have 1/12 y to the third minus y squared plus 4y from 0 to 3. Now the nice thing is since every term has y in it, what happens when I plug in 0? It's just 0. So just plug in 3. So I have pi times 1/12 of 27 minus 9 plus 12 gives you plus 3. All right, and adding, actually, you can reduce this by 3, right? So you get pi of 9 over 4 plus 3, which becomes pi. Oh, wait. I put the wrong value, didn't I?
It's supposed to be 4.
It's supposed to be 4. Something was wrong there. So that's 64 over 12, which does reduce, minus 16 plus 16. Well, that's nice. Weapons of minus 16 plus 16. They cancel. And 64 and 12 reduce to 16 over 3. Hey, look, our answer from before, because we know volume of a cone. 16 pi over 3. That is it for the notes. So let's flip this over, do some practice questions.
Can you give the number 11?
It says calculator allowed. Okay. Second. All right. So, since we're revolving this around y, we do need this in terms of y, correct? Which means first thing I want to do is multiply by what? Yeah, multiply by 2401 over 9. So 2401 over 9y equals x to the fourth, which means x is equal to the fourth root, or just 2401 over 9y to the 1/4, which is why calculators allowed when you do the integration for this. All right. So since that is my function, what are my values for y? What's my bound from 0 to what? 7?
7.
Yeah, 0 to 9, right? Wait a second, let's read this question. The important favor looking to mixing bowl to bowl shape and maintained by revolving from x equals 0 to x equals 7. Let h be the depth in centimeters. How fast was the height of the depth of gelatin bowl increasing when h is equal to 4? Okay, so that means that I'm going from 0 to 4. It says my max height is 9, but it didn't say how much it actually went up. It says the max height, how fast it's increasing when h equals 4. So, so this gives me what? Pi 2401 y to the 1/4 dy. Squared, yeah. Now, that's going to give me pi 0 to 4 of 2401 over 9y to the 1/2, right? Because when you square 1/4, you get 1/2. Is 24 over 1 a perfect square? So what? It is. What's the square root of 24 over 1?
Oh,
It's obviously 49.
really?
Right.
So sorry.
Well, yeah, obviously. No, it is 49.
Um,
Again, you have a calculator. What's second? Yeah. Back here. Square root of 24 over 1. 49. Yeah. Just use a calculator, guys. So we can rewrite this as pi integral of 0 to 4 of 49 over 3 y to the 1/2 dy. So what is the integral of that? Because you can move the 49 over 3 out, can't you? So 49 over 3 pi. What's the integral from 0 to 4 of y to the 1/2? I know it does say calculator aloud, but you don't actually have to use
Why?
it. So yeah, 2/3. Is it 2/3? Because you're adding 1. So yeah, it is 2/3 y to the 3/2. Let's say, what's going on here? Oh, we actually don't need to do that. So let's go back and read what they want to know. Mr. Burst is pouring his favorite liquid into a gelatin mixing bowl. Bowl shape is that right there. The gelatin poured in an empty bowl at a constant rate. So the gelatin poured into is a constant rate. So that means that the dV/dt, the volume, dV/dt is equal to 14. Now, why are you doing that? This right here, all right, volume is equal to 49 over 3 pi times the integral of y squared from 0 to, well, 4 in this case, dy. So what do I need to do to this? Well, sorry, 1/2 it. We would take d dt, right? Because I want to know how fast the rate's changing. What happens when I take the derivative of an integral? It goes away. Now y becomes what? Actually, I don't need. I have to also include, since I don't have a t, right? I have to include what? dy dt, which is what I'm looking for. So we know dv dt is equal to 49 over 3 pi y to the 1/2 of d what? Well, actually, no, not y to the 1/2, because I'm actually saying y is 4. What's going to happen to the 1/2? Sorry, what's going to happen to the y? It's going to become square root of 4. dy dt.
Where did the square root of the 4 come from?
Because I actually have an upper bound here.
Oh.
Yeah. I still have to plug it through the integral. So,
Oh.
now we have 14 is equal to 49 times 2 over 3 pi dy dt, in which we could just multiply by the reciprocal, right, to get dy dt?
Which one part of it? Oh, square root of 4 is 2. Where did the 14?
Right here, dv dt was 14.
Uh,
So that's going to give you 14 times 3 over 49 times 2 pi equals dy dt, which reduces by 7 2, 7, 2. So 3 over 7 pi is equal to dy dt. I don't know why you have to do that one. It seems pretty straightforward, right? All right. How much time we got left?
Too much.
Oh, we got 10 minutes left. Doing no problem. Now, make sure you do read these because some of these do say set up but do not evaluate. So only the first 4 you have to evaluate. Everything else is just set it up. Set up the interval.